In some machine learning use cases, the ground truth is instantly available. And a way to what we then can do is we can compare the target with the model output and measure some type of error or loss. And this is an example of a classification model, but for regression models, it's exactly the same, where we look at a performance metric during the reference periods. This is ideally testing. And then we deploy the machine learning model, and we can look at the performance metric over time. And typically, these performance data points are created by aggregating data, hourly, daily, monthly, yearly, and then we can see how the performance changes over time. And if the performance drops under a certain threshold, or for regression models, when the loss grows over a certain point and the aggregated error becomes larger, it's then that we will throw an alert and that we will have to delve in deeper and do some investigation of why our models are less performant. And a typical example in a regression use case where ground truth is instant is, for instance, if we're or almost instant, if we're predicting expected time of arrival of cars or planes, then a few hours later, we will know how far off we will be, and we will have gotten the actual target or ground truth. Also, if a customer is on our platform, they're doing certain action, we can then try to predict how much they are going to spend. That is also something that after the customer has spent a little bit of time, we know instantly how much they have spent if they do a checkout, and we can compare and we can have clear view on the performance. Now, in many use cases, the ground truth or the actual outcome is delayed, and it takes a while before the outcome actually comes in. And that creates this problem that we can't calculate the performance during that period. For instance, if we do demand forecasting over a certain window, we want to predict the amount of a call center, or we want to predict energy demand for customers for the coming 3 months. We only really know at the end of that window what the actual demand was. And we need, of course, the demand to compare it with the model output to get some type of performance measure. And what we will then have if we start measuring performance is that at inference time, when the model makes the predictions, we can only see the performance of the model, how the model was doing like a few months ago. And that is, of course, problematic, because if we don't have a view on the performance, we can't also really know whether our machine learning models are still making the right decisions. And then there's a third case where the ground truth is completely absent. And this typically happens in automation use cases. We can think insurance pricing. I see that Mike raised his hand. By the way, Mike, you can just drop your questions in the Q&A, and then Wojtek will answer them as we go along with this presentation in the chat. And at the end, there is like 15 minutes left, 20 minutes, where we will pick out some questions and have a discussion about it. Same for you, Delio. You can just put your questions in the Q&A chat box. But for instance, if we do automation use cases and we do insurance pricing, and imagine that certain insurances used to be priced by an analyst, and that today we replace these analysts by an algorithm that mimics their behavior so that these analysts can focus on more important things, then this algorithm actually removes the process of what was used to be price setting. And then there's no ground truth generated anymore, and we have no view on performance at all. And what we will see here is that at the target, when we go into analysis, that there is no ground truth generated, and we're completely in the dark when it comes to the performance of our machine learning models. So again, in summary, there is 2 issues that cause silent mode failure, which is covariate shift and concept drift. Both can also interact with each other. And then there's this type of third dimension, which makes it hard to monitor machine learning models, and that is the availability of the ground.